Hello, this is Mike Lynn, Corporate Metrologist here at IndySoft, and today I'm going to go through some of the changes we made for version 14 involving specifications. Historically, we've had the Specifications tab. Previously, it was known as the Uncertainty Attributes, and we had these formula, lookup, set, and table items. And while some of these are still useful in certain scenarios, we've added a new set of features that extend well beyond those original specs. The first thing we've added is what's called Spec Manager or Specifications Manager. This allows us to maintain and manage a list of equipment manufacturer specifications, or in some cases, organizations such as ASTM, OIML, and ASME. So as you can see here on the left side of this panel, we have a tree structure that shows the manufacturer model specifications. We can search by the name of the specification. We have what's called meta tags that allow you to add terms for searching. You can search by a revision name or status, such as archived, in process, or current. You can also search by the manufacturer model number. So let's say we want to find a Fluke 5522. You can see here we've got 5520, 22A, and 22 SC1100. So under here now we can see we have a current revision for that. Over here on the right side, you can see the information about the revision, who approved it, where it came from, how it got here. You can attach documents to justify the specifications. We've got a section for notes. So every time you create a new revision, you can have, you set one for current and it archives previous versions. Now, when you attach an instrument to a specification, it's tied to the revision. So as you add revisions, it gives you the choice to go in and update to the new revision of the document or leave it connected to the old revision. In situations where you may have devices been around for many, many years, when they first were manufactured, they had one set of specifications, and then multiple years later, they manufactured it with slightly different specs with different manuals that came out. So this allows you to handle both situations. So now if we go to the specification itself, you'll see here we have a tree structure on the left that many will be familiar with. So let's take a look at the individual specification revision. So as you can see on this, we have a tree structure here that's similar to what you may have seen in other packages. But we approach this a little bit differently. One of the things that we noticed people who were migrating into IndySoft from other software was that there was an inconsistency in the way their data was structured in terms of specification. There were situations where you would have a technician would enter in AC space volts. Another one might do volts comma AC. A third might even do AC underscore volts. So there were three different methods or three different descriptions of the same parameter, and it makes it difficult to search across equipment when they're not structured the same, when the terminology isn't the same from equipment to equipment. So we approached it from the idea of being equipment agnostic, that if all DC voltage sources are structured the same way using the same terminology, we could just search across all those devices for the term volts underscore DC, and we would be able to find what we're looking for. So as I go into these, take this AC voltage here, you'll notice that I have a parameter 1 and a parameter 2 of frequency, and then this actual specification that we're dealing with. So if I click on here, what we've done is we've taken this tree structure and flattened it out into a form to make it much easier to enter the data. We've also taken all of these different bits and pieces of data and put them in a managed list. So everything is from a drop-down that is now managed so that you can be sure to use the same spelling, same capitalization. So everything is the same across devices. It makes it much easier to be able to find what you're looking for. Those are managed over here in the main client under your add edit lists. So if I go down to system wide and go down to specifications, you'll see I have the contributing items here, which you can add or delete from this and change whatever you want. Parameter 1 and parameter 2. So for every parameter 1, you may or may not have a parameter 2. So let's say hardness Rockwell. So you see you have all these Rockwell hardness parameter 2 that breaks it down. So this allows us to maintain consistency across all the different devices. So I'd mentioned some of the organizational type specifications. So if I come back over here, I can clear these out. So here you can see I have ASTM EC617 classes and OIML classes. So I can go into here and you'll see I have all the different masses, and this comes straight out of the standard. This is right out of the tables of the standard, and it allows us to have the tolerancing for building test points and things of that nature. So as you can see here, how you can tie an individual mass to its accuracy specification in Spec Manager. So we have specifications for class type situations. There's a weight, so I can go to, say, gauge blocks. I've got ASME B89 grades in here. So you can see how it comes, like I said, directly out of the standard, out of their tables. Now, what happens if you have a situation where you have a device that maybe has a limited calibration? So it would normally be tied to the manufacturer's spec, but maybe this particular device has something wrong with it, that it has a limited range or a different specification for a customer or one-off kind of situation. Well, what we can do there is push the standards or the specifications from Spec Manager down to what we call structured specs. It's a very similar concept. It's structured the same way. The tables are almost identical. But what it allows us to do is push the specification for individual spec entries down to the instrument level. So in this scenario, this particular 5522 has an issue with the volts AC square wave. So what happens is when we do our lookups from the uncertainty module, it's going to look here first. If it finds it, great, it uses it. If not, then it goes to Spec Manager to find that information. So this acts as an override for whatever the manufacturer has spec'd. This is also where we would store our inherited calibration uncertainty for this particular device. So when you get the certificate in from the manufacturer or whoever it is that's calibrating it for you, that data would go here, and now we have a place to look it up for our uncertainty budgets when this device is being used. So we also have a new concept. I shouldn't say a new concept. It's a revision to a previous concept that we had under here called, in the general specs, we had the set items. The way this was structured really wasn't working the way we intended it to. So we've created a new variation on that that actually works fantastic now. So let me go to an item that has multiple devices in it. It's a set. So we have a gauge block set, a 35-piece gauge block set. So this is set up as one asset. You may also see this with mass, where you have a mass kit with individual masses in there. Some people break out those masses as separate asset numbers. Some people don't. So it depends on how you want to do that. But the set's structure will work with either way. So we have this 35-piece set. So if I come over to the Sets tab here, now you'll see that we have a line entry for every item in that set. So there's 35 individual lines here. If I open this up, you'll see that I've got the nominal value and its unit, its error and a unit, it's the uncertainty of that error and a unit. And then here I have additional information that I can collect about that individual item. You know, if you have a set of blocks, maybe it's a mixed and match of different materials, different CTEs, things like that. This will handle that, no problem. So this information here is created and managed the very same way the equipment attributes are. If you're familiar with the attributes, now if I come over here to my add edit list and go down to set types, you'll see that I have these different set types created already. Just some things I was thinking that could be put into sets of items. So if I look at my gauge block, you'll see that I have this information here. I could add in here, let's say the material, maybe the shape, whether it's square, rectangular, whatever. There's additional information, whatever you want. You've got 10 custom numbers, each with a unit and a custom text field. Now for weights and masses, I may collect different information. So I have the ability to reuse these fields over and over again to collect different information. But like I said, you may recognize this as the very same structure that we use for the gauge attributes. But these are per individual item in the set. So let's go back to our equipment here. And just to show what it looks like, we'll go to, I think it's 12. Yeah, it's a metric or a weight set. So I can open this up and you'll see that I've got nominal value, error, uncertainty, and then I have those fields that were set up to collect additional information. So now what this allows us to do is to go in and be able to identify and manage the information for each item in that set. It also makes a change to the way you can do calibrations. So let's show, for example, let me go to this device here, which is a micrometer. So I have my default masters, I have that gauge block set, I've got my test points here, I've got the uncertainty budget set up with a link to the test points. So I can come in here and I can start a calibration. So I've got my main screen here. There's my masters with my uncertainty mapping showing at the bottom here, showing that my master rule requires something called gauge blocks, which we have. Now, when I get to the results, what happens is we have a different mapping panel now, so that what's happening is the system is looking at that first test point, number one, what our nominal is. It's then also looking at what's in the set of gauge blocks that's available. And it goes through and runs an algorithm to suggest to the technician which gauge blocks they need to reach this point right here. So that we have several options that you can use. You can set it up for automatically loading the suggested. You can have it whether it's closest to the standard or using the lowest uncertainty, how many paths that you want to be able to run, whether or not you have, how close you want to be able to get to the target value and still call it close enough, if that makes sense there. And then we can suggest paths and path selection. If they don't want anything they want, they can take these out just by double clicking them. There we go. And then they can add back whatever they want. They can select from the list. So it gives everything. You can use the error of the blocks or not, but it keeps track of where you are, how close you are to it, whether you've hit the value or not. And it's a really neat thing here. So this is a quick look at what we've done in terms of specifications and some of the changes that we've made. And if you have any questions about it or anything, just contact us at IndySoft and we'll be happy to answer any of your questions. Have a great day.